We've been doing confidence interval calculations for a single mean for a while now, and today we're going to take a look at robustness of t-procedures. An inference procedure is robust if probability calculations remain fairly accurate even when a condition is violated. That means if we're creating 95% confidence intervals, the procedure will be robust if 95% of those intervals would capture the true value of the population mean in the long run. Let's take a look at a highly skewed distribution and small sample sizes of 5 and see if the intervals that are created are robust. So let's sample some cases, and let's sample 5 cases. And we can see that there are 5 cases in here with values bigger than 2 and smaller than 2. Notice our mean is about 2. Now let's create a confidence interval based on these 5 values. We're going to create a confidence interval for a single mean based on these 5 values. So we've got our sample count, our sample mean for these 5 values, our sample standard deviation, our standard error of our estimate, which is our standard deviation divided by the square root of the sample size. And we can see that this particular interval ranges from a low value of 0.71 to a high value of about 3.04. Notice this particular interval did capture the true value of the population mean, which is a little more than 2. Let's gather several confidence intervals. So I've created 5 different confidence intervals. And let's see what we've got here in terms of what's been gathered. We have a sample mean for each interval, a lower confidence bound, an upper confidence bound, a confidence interval width, our sample standard deviation, standard error, degrees of freedom, which is our sample size minus 1. Our attribute is value. That was the name of this particular set of data. We have our confidence level of 95% and our sample count of 5. So this interval captured the truth. It has 2 contained within the lower bound and upper bound. So does this particular interval, but not this one. This one contains 2, and this one doesn't. Now I could go through every single interval and decide whether each interval captured the truth or not and keep track of those, but it'd be nicer to have Fathom do that for us. So I'm going to create a new attribute called capture, and I'm going to edit this attribute. And so if my lower bound is to the left of 2, we'll say our mean is about 2 for this distribution, and my upper bound is to the right of 2, then that interval will have captured the true value of the population mean, which is around 2. So here's what we're going to do. We're going to say lower confidence bound has to be less than 2, and our upper confidence bound has to be more than 2. Let's see what that did. That created a value of false, and this particular interval does not contain the number 2 within these 2 bounds, so this interval would not have captured the truth. But then notice here we have the word true, and this interval did capture the truth, did capture the value of 2. So every time we see a true, that means that the population mean is contained within the interval, and every time we see a false, that means that the number 2 is not contained within the interval. Well, we'd like to do this more than just 5 times, so let's do this a total of 100 times. So we're creating 100 different confidence intervals based on samples of size 5. And so I have all my different intervals and I have my trues and falses here, but it'd be nice to have a summary of this rather than having to keep track of this ourselves once again. So let's create a summary chart and see how well our 95% confidence intervals did here. Did they capture the true value of the population mean at a rate of 95%? Oh no, this one only captured at a rate of 82%. Let's try again. Collecting some more measures, let's see how we do. Now we have an 82% capture rate. That's not good. and now an 88% capture rate. Are we ever going to get a 95% capture rate? These are supposed to be 95% confidence intervals. That's only an 88% capture rate, and now an 89% capture rate. This is not performing well. And the reason for this not performing well is because our original distribution was highly skewed and our sample size was only a sample of size 5. So here's some questions I'd like you to think about. What if our sample size was 15 or 30? Would 95% confidence intervals perform at the 95% level for that same distribution? Or what if the original distribution was approximately normal and n was 5? Would 95% confidence intervals perform at the 95% level? These are some things that you can think about over the next day or two, and perhaps you might even want to use Fathom to investigate these questions.